Right. So in the previous video, we have discussed what a function declaration is. So in other books, this function declaration is also called as the function prototype. So in the function prototype, you are just giving your compiler a brief glimpse about the properties of your function. Okay. So for instance, you have your compute average, and its return type is double, and it has two parameters with both having a double net types. So, all right, so we also have the function definition. Okay, so the function definition is simply a block of code that performs a specific na task. All right, so here's an example of a function definition wherein this first line resembles your function prototype, and inside are the set of tasks that your compute average has to perform. Okay, so here's the general syntax of a function definition. So you have the return type followed by the function name and followed by the parameters that are enclosed within your parentheses, and then inside the braces are the declarations as well as the statements that it needs to execute. All right, so let's start with the return type. So the return type, as we have already discussed, is simply the type of value that the function returns. So for example, in the compute average na function, you know that the the compute average computes for the average of two double values, and in turn it should return a double. Okay, so you are basically telling your compiler that this function compute average will return a certain type, which is double. So the functions may not return arrays, but there are no other restrictions on the return type. So, and also specifying that the return type is void uh, tells that the function doesn't have a return value. Okay, so and lastly, if you omit this return type, so in other words, you only have the function followed by the parameters. So your in C89 na version, your compiler will presume that it returns a type of int. Okay, so we also have the parameters. So each parameter is preceded by its data type. So for instance, we have this argument 1, argument 2. So each of this argument should be separated by comma, and it should be have its data type. So if the function has no parameters, then we indicate that it is void. So a separate type must be specified for each na parameter, even when several parameters have the same type. So in this example, compute average, it computes for the average of two double na values. So even if A and B have the same type, so we have to explicitly tell the we have to explicitly indicate that A is double and B is also double. So this example double A comma B is wrong because we only specify for the type of A but not double but not B. So a function, a definition has also the function body. So the body of a function, it contains the block of code to perform a specific net task. So it may also include both declaration and statements. So for example, this compute na average na function, we declare a variable na sum, and then that sum will store the sum of the two variables A and B. And then later, we have a statement which returns the result of this computation sum divided by 2. So there are just some reminders. So this variables that have been declared in the body of the function belong exclusively to that function. So we will delve deeper about the scope and lifetime of variables in the next lecture. But in here, again, um, since this sum was declared inside the compute average, this sum will not be accessed by other functions that are declared inside your code. Okay, so but let's say you add another function function that uses the variable sum, then that will also be fine. Okay, so uh, also, the body of a function has return type is void, can be empty. So, example, here we have the return type void for your print function, also having a void argument. So, leaving the body empty may make sense during the program development. So, we can leave a room for a function without taking the time to complete it, then just come back later and write the body.